I am Chiklangu Manito, and this video is a project for concrete technology in measuring slump test and curing concrete into cubes. It's known that engineers work in pairs or groups. This practical was performed in a group of 7, and the aim was to determine the slump test results and the factors affecting fresh properties of concrete. Since the definition of concrete is simply a mixture of cement, water, and aggregates, a mixed design was brought forward by using South African standard of concrete to calculate the amount of each specimen used. Types of sand such as crusher sand, river sand, and slag sand were provided, and crusher sand was chosen. Sand, stone, and cement were collected and their masses were measured using a mechanical balance. The masses that were weighed were the same as the ones calculated on the mixed design. The cement and the crusher sand were first mixed together in the working place before adding stone and water all together. After a few minutes, few stone content was added into the cement and crusher sand mixture with a careful handle of the bowl. The mixing process was handled in such a way to avoid segregation at the end of the practical. Segregation being the separation of coarse or fine aggregates from the concrete mass. The remaining stone content was then added to the mix, and this was to ensure that the mixture is perfect. Later on, water was added to the mixture of cement, sand, and stone to then produce concrete. And taking into consideration that the water-cement ratio favored the cement, water was little, and this helps the strength of the concrete to be strong, because if water is little, then the aggregates together with the cement will then be solid earlier. After adding water, the process of mixing had to be fast, and this was because concrete gains strength as it hydrates and hardens. And if concrete hardens, then it becomes difficult to mix, which will require a lot of energy, and that affects workability. Since it was hard to mix because water was little, then workability was affected in this group. A few moments later, the mixing was done and the practical was halfway to the end. A slump test was begun. The mold cone was filled with compacted concrete. Concrete was compacted into 3 layers, with each layer tempted 25 times to ensure an even distribution of concrete. After the first layer was tempted, a second layer was created and it was also tempted 25 times, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And the same number of temped and tempting method was also used on the last layer. The tempting method was performed using a 600 mm long bullet nose metal rod with diameter 16 mm. And even though the tempting appears to be fast on the video, the layers were actually tempted slowly to make sure the counts were accurate. And as the cone was filled with concrete, the top of the cone was slided so that the concrete leaves the top of the cone. And then it was leveled using a rod. At the end of that stage, the concrete was struck off flush with the end of the mold. The mold was then gently pushed downwards and slided. And after some few seconds, it was then lifted upwards in a gentle motion. This was to ensure that the mold doesn't affect the concrete. The concrete subsided, and this subsidence is known as slump, and it is measured to the nearest 5 mm if the slump is less than 100 mm, but also measured to the nearest 10 mm if the slump is greater than 100 mm. The measurement from the top of the slump to where the rod is was measured to be 30 mm. With the cone having a height of 100 mm, this means that the height of the slump is 70 mm. If you take a close look to the concrete cone, you can see that it is bleeding, but the bleeding is not excessive and it is neither least. The bleeding is average, which is good for the concrete. The slump test is suitable for slumps of mediums to high workability. We had outstanding results, meaning that the slump test was successful and it was measured appropriately. Immediately after the slump test, we discussed about tapping the non-absorbent board so that the concrete could sag and we would place it in the pouring cubes. Since the slump test was done, the cube molds were then applied with a non-stick material. This material was applied to help ensure that the concrete doesn't stick to the cube mold. After the unsticky substance was applied into the cube molds, concrete was then compacted into the cubes. The compaction of concrete into the cubes was monitored by the method of tempting. 3 layers were also tempted onto the cubes, with each layer being tempted 25 times to ensure an even distribution of concrete inside the cube. After the concrete was compacted into the cubes were then given identities. They were numbered from 1 to 3 because they were 3, and then they were placed in the lab to harden. After hardening, the cubes were then placed in the curing bath, and that was for compressive strength purposes. The naming of cubes from 1 to 3 as a label helped the group because they were easily identified. After the cubes were taken out of the curing bath, they were measured to check the dimensions if they are still compatible or still in the same shape. All the dimensions for cubes were all summing up to 10 mm. The compressive strength was then measured in the lab. The compressive strength was measured for all the cubes, from the first cube to the third cube. The first cube had an acceptable failure. It had a strength of 19.375 MPa. The second cube failed more than the first cube, and it had a compressive strength of 18.340 MPa. The third cube also had an acceptable failure. It also had a maximum strength of 19.375 MPa. The average maximum strength was found to be 19.375 MPa, and this resulted from the fact that the cubes were not cured in the same day they were supposed to be cured. They were cured later, and this resulted into a huge failure. With group 1 being the control group, its maximum strength was supposed to be higher than all the other groups, but it was not because of a single mistake of curing. So in other ways, curing is important because it plays a huge role in the compressive strength of any concrete material. Comparing the slump of group 1 and group 2, group 2 had the best slump, and their conical cone mold was removed gently and in a proper way, and their concrete had no excess bleeding. However, they were not able, or they didn't know how to measure the slump test by putting the ruler and measuring. But the important thing is that they finally found out how to measure it, and they did measure it, and everything went well. Most groups, including group 2, group 3, and group 4, their cubes didn't have so much of failures because they cured their cubes on time. Unlike group 1 cured their cubes later on. That's why they had a major failure. The practical was successful, even though most groups didn't get what they expected to get. And factors that affect fresh properties of concrete, such as segregation, bleeding, cohesion. They also affected the practical. Thank you.